Obviously, the last week has been very eventful in terms of new knowledge on ice melt. And it looks like the same team that produced this landmark paper about Antarctica a week ago has now come through with an additional study of Greenland that it looks very impactful. So I wanted to run that by you and see if you had a chance to read it.
Yeah, I have read this study. The new one on Greenland is really magnificent, and a lot of us have been waiting impatiently for this study to come out because we've seen pieces of it so far, and it has really kind of revolutionized the bed topography, the map of what's underneath the ice, by adding a lot of detail to that, using ice flow conservation method. Previous to that, there was a few lines going across various under ice channels, and these lines just didn't give detail where it was needed. You can't have a channel flowing through where there are these big bumps that were implied by these radar profiles. What this study did is, through this mass conservation, it matched the surface velocity with the bed profile and produced a much more realistic basal terrain shape that is consistent with mass conservation. And what it did was create a lot more area of the Greenland ice sheet that is below sea level. Those glacier troughs that the glaciers are terminating in the sea, that many of them are underwater, and they extend inland into the island. This study has actually moved the underwater, below sea level part of glaciers on average more than 67 kilometers further inland, and so that means that the Greenland ice sheet will remain more vulnerable to the effects of the ocean triggers on glacier acceleration than what we previously thought. The study concludes that even by the end of this century, at the retreat rate that's been observed of over 100 meters per year at these glaciers, many of these glaciers will still be marine-based by the end of this century. So that really kind of adds to the ocean vulnerability that in 2008 was identified as the trigger effect for some really rapid changes in Greenland glaciers. So this study brings kind of back into play the Greenland glaciers, whereas there was this tendency to start to conclude that, okay, these glaciers will simply retreat out of the water and then there won't be an ocean trigger effect anymore. Well, that's not going to be true for some time for most of the widest and fastest Greenland glaciers.
Okay, do they give kind of any estimate of increased sea level contribution?
What they've really provided is a greatly improved data set, a map of the bed of the Greenland ice sheet. And with this data set, that's what's really been eagerly anticipated. It will really help ice flow models make a much more realistic um, calculation of ice flow. Many previous studies by a lot of smart people have been published using a poor depiction of the glacier bed, and this boundary condition was simply off. And this new data set has more precisely incised glacier flow channels that will enable the ice flow modeling to just provide a much more realistic and accurate depiction of the boundary conditions. It's been shown over and over that you really can't simulate a glacier flow without a realistic bed shape, and now we have that.